This is Chapter 7, Example 2. We did this example before. We're going to do it a little bit differently this time to show that it can be done multiple ways. So the first step in this problem is to look at this circuit and write an equation for it. What this equation is saying is the locations of, we'll say, the ones in the circuit. So last time we went through kind of a long way to do this. This time we're going to do it a little bit differently. We're going to interpret this differently. We're going to take this a term at a time. This is A, B naught, and what it says that anytime A is a 1 and B is a 0, the output is a 1. The C does not matter. And same with this term. Anytime A is a 0 and C is a 1, the output is a 1. The B does not matter. Now, the last approach to this problem, we factored it out, we expanded it, and it was just a viable approach, but this is a little bit differently if you know what you're doing, so hopefully you'll know what you're doing. First step in this thing is to mark these off. What I've done here is mark off all the different input combinations. So here we go, term at a time. I'm looking for cases where A is a 1 and B is a 0. A is a 0. A is a 1, B is a 1. That's not what I'm looking for. A is a 0. A is a 1, B is a 0. So at this point we know the output is high. A is a 1, B is a 0. Got that high. A is a 1, B is a 0. Okay, so we found three locations where A is a 1, B is a 0. We marked those as highs. The next term we're looking for A is a 0, C is a 1. A is a 0, C is a 1. A is a 0, C is a 1. A is a 1, we don't have to worry about that. A is a 0, C is a 0, that's not what we're looking for. A is a 0, C is a 0. A is a 0, C is a 0. A is a 0, and C is a 0. At that point, anytime that it's not high, it's low, which is these terms here, and we are officially done with this problem. So this is the alternative way to do a problem like this that's different from the previous example.